Hello, guys. Here we go. We got lesson 2.5, which is implicit differentiation. Kind of continuing on with different ways that we can find derivatives. And today is no different. Starting with the kickoff here, we have y equals x squared plus 1 to the third. So we have to do chain rule here. So derivative of the outside is where we're going to do the power rule with the 3. So y prime will go to 3 parentheses x squared plus 1 squared. And then chain rule part kicks in. We have to do derivative of the inside, which would be a 2x. Now, the one thing we're going to do is we're going to take the 3 and the 2 and multiply it to get y prime equals 6x. X squared plus 1 squared. Now, we could go through and we could square out the x squared plus 1 and then distribute the 6x in and solve that out. We're just going to leave the kickoff as that for right now. So, biggest thing with this, as we're going through the videos, keep in mind, at any point in time, you can pause it to write stuff down, get caught up, or go back through, rewind, and hear it again. I'll try not to go too fast, but I know I will probably go too fast at times, and I'm sorry for that. But keep in mind, you can always do that, watch it again, rewind it, or pause and do that too. So, first stuff we've been doing is we've always done derivative of y with everything in terms of x. So it's just, okay, derivative of x squared goes to 2x. It's just that, just straight up, as you see it there, which is explicit differentiation. However, when we get into multiple variables on a side, we're going to use implicit differentiation. We're kind of doing the chain rule while we do this because we're going to assume that y is differentiable, that we can find the derivative of it. We don't know exactly what y is on these other ones that we've done before, but now we're going to get into, okay, well, if we have multiple variables, how do we get the derivative of all of those? So, explicit differentiation there. Again, we're doing derivative in terms of x, so we have an x here, so we do it, boom, we get our 3x squared. When our variables don't match, we're doing derivative of d in terms of dx. So the derivative in terms of x, even though we have a y here, we still carry it out, but then we chain rule it and go, okay, whatever y is, that'll be times the derivative of it. So think that's that chain rule coming in. Derivative of the inside times derivative of what that variable would be. So here again, we get a little more crazy. We're going to end up doing the product rule and the change rule at the same time. So because we have an x and a y squared, those are two different functions that are being multiplied. That when we do the derivative of, we're going to start, we can do derivative of our x. Actually, I got this the other way. We have our x times derivative of the second plus our second times derivative of the first. Well, this part we can just do and we get our 1 here. However, when we do the derivative of the y, we have to have this dy dx. So essentially, when it's something other than an x, we have to have that dy dx on the back side of it, which is using the chain rule to have that there. But this is what ends up being then is the 2xy dy dx plus y squared. So that's really what we're going to be doing in this one here. Some guidelines that we follow. So before, like if I go back to this top here, we just said, okay, derivative of y being the equation, we're just going to say y prime. Well, now we're going to differentiate this side and differentiate the other side when we're doing implicit. We're going to collect all the terms involving dy dx on the left side of the equation. So move everything to the left side of the equal sign. Everything else goes to the right side. We're going to factor out that dy dx and then solve for it. So let's do one. So find dy dx given y to the third plus y squared minus 5y minus x squared equals -4. So if we do the derivative of y to the third would go to 3y squared, but again it was a y, So it needs a dy over dx. So all that's saying is we want to do the derivative of y in terms of x's. Dy dx. It's just mean derivative there. Plus derivative of y squared, we go to 2y dy over dx. The 5y, we minus 5 dy over dx. Because derivative of y just goes away and is that the whole number in front. And then minus x squared, so minus 2x. That one was already have our x's in it, so we have to do a dy dx. And derivative of any constant is 0. So everything that has a dy dx we want on one side. Our other one, anything that doesn't have it, we're going to move to the other side. So we're going to add the 2x to the other side. And so we're going to have 3y squared dy dx plus 2y dy over dx minus 5 dy over dx equaling 2x. So we got everything that has dy dx on one side, everything else on the other. Now we can pull that dy dx out. So we would have dy over dx. So if I pull that out, what would be left of the first term? The 3y squared. Plus then 2y minus 5 equaling that 2x. I'll ask you to solve for it. We would divide everything by that. The 3y squared plus 2y minus 5. When we do the one side, we have to do the other side. So that's gone. So dy over dx would be 2x over 3y squared plus 2y minus 5. Okay. So as you work through this, if you have questions, again, go back through, watch it again. Otherwise, send me a message, and I will try to address those questions. But just know that, hey, keep working through it, and we'll get it figured out. So we're going to go through, we're going to find derivatives of these. So the first one, derivative of x squared, well, would be 2x. Actually, before I go too far, do you guys remember what this equation is? I know this is kind of rhetorical because I'm talking to a camera, and you guys aren't here to respond, but this here is actually what we're doing here are the equations of a circle. So if you think about it, x squared plus y squared would be a circle that's centered at the origin because there's no minus h minus k. Our radius is 0, so this is actually going to be a point. So this one is actually not differentiable. This one here, though, radius of 1, so we can do this one. This one then would go to 2x plus 2y dy over dx equaling 0. Because derivative of any constant goes to 0. To solve, we'd subtract the 2x to the other side. So 2y dy over dx would equal negative 2x. We would then divide by 2y to get rid of it there. So dy over dx would equal, our 2's can cancel, a negative x over y. All right. This next one, we're going to actually solve for y first. So we would move the x to the other side. So y squared would equal 1 minus x, and so then we would square root. So y would equal the square root plus or minus of 1 minus x. So in this case, where are we going to be able to find the derivative of this? Well, whenever our y then is on the plus side, when we're greater than 1, on the minus side when y is less than or 0, not ones. So, I was just looking at my answer sheet, and I am totally should have been doing this on these other two. This first one, not differentiable. Here we really got to look at, well, where is x or is y going to be? So again, if we would solve for this one, which is what I should have done here instead of doing the derivative of it. I got a little carried away there. Sorry, guys. We would subtract the x squared to the other side, and then we would square root to cancel out the square. So y would equal plus or minus the square root of 1 minus x squared. So where this one here is going to work is from -1, so less than x, to 1 is where it'll be differentiable at. That was my bad. Sorry, guys. So what this part is really doing is it's looking for, well, where will we be differentiable at? Because remember, to be differentiable, we have to have the point exist, the limit on either side has to exist, and the limit and the point have to be the same to show that it's continuous everywhere. That if it's not continuous, well, then we can't be differentiable. So where are we continuous at with this circle? Well, when x is between -1 and 1. Outside of that, it's not going to work. Here with square roots, we can't have a negative under the square root. And I had that wrong. It is 1s. So when we're positive, we want y's to be greater than 1. Less than 1. Wow, I really messed this one up. Sorry, guys. So yeah, we have to look at, well, what y's will exist. We can't be a negative underneath the square root. So we have to be greater than 1 for in here, and we have to be less than 1 in here. I'm probably just making this more confusing, so we're just going to move on. How about that? So determine the slope of the tangent line to the graph of x squared plus 4y squared equals 4 at the point square root of 2, comma, negative square root of 2 over 2. So remember, taking the derivative, it gives you the equation, and then you can plug in to find the instant slope of that point. So we're going to do the derivative of this equation. So derivative of x, because it's an x, we can just do it straight up and get a 2x plus derivative of 4y squared. We go to 8y dy over dx. Because y squared, we'll go to 2y. We already have a 4 there, so we get an 8y. The 4 just goes to 0. So if we solve for the dy dx, that will give us our equation then, that we can then find the slope of the graph. So if we subtract the 2x over, 8y dy over dx would equal negative 2x. And if we divide by 8y, we are dy over dx of, well, the 2 and the 8 can reduce. This can be a 4 and a 1 of a negative 1/4, or negative x over 4y. Wow, there we go. So that's going to be our equation then that we can find the slope. Now, at that point, if we put that negative square root of 2 in for the x on top, and then we would put in the y value on the bottom, because in this case we have both the x and the y, where in the past we've always just had an x, so we take the x, plug it in, we get our answer. Here we have to put both of those values in. When you do that, you're going to end up with a 1/2. So that's what our slope would be then. So go through, find the derivative. Once you have the dy dx solved for, Then you can put your x and your y in, and then finish solving it out to get your slope when you do those. So, find the slope of the graph of this right here. Now, just like before, sometimes we'll have to do chain rule, sometimes we'll have to do the power rule, the quotient rule, all that stuff comes into play. So when we do this first one here, we're going to have to do the chain rule. So derivative of the outside, we'd move the 2 down with the 3 to make this 6x squared plus y squared. And then it'd be to the first, so we can just leave it as such. And then times derivative of the inside. Well, derivative of the inside, we go to 2x plus then our 2y dy over dx equals. So now we do the other side. X and y, we're going to have to do product rule here. So 100 is just going to be out front. Derivative of x would just be 1, so we'd have y, plus derivative the other way would just be x dy over dx, because derivative of y would go to 1, but because it was a y, we have to have the dy dx. So from here we can start simplifying. We can distribute our 100s in. We can distribute the 6 in to each one, and then we will FOIL with what's in there. So 6x squared plus 6y squared times then our 2x plus 2y dy over dx equals 100y plus 100x dy over dx. So from here, we don't necessarily have to FOIL it completely in, but we do have to distribute what each one has so that we can pull this out. And we're actually going to do it the backwards way with this times these. So what we're going to have here is the 2x times our 6x squared plus 6y squared. And then our plus our 2y dy over dx times the 6x squared plus 6y squared, which is equaling our 100y plus 100x dy over dx. So what that allows us to do is we're going to get everything on the one side that has a dy dx, everything that doesn't on the other side. So doesn't have a dy dx, we're going to move this to the other side. We're going to subtract our 2x 6x squared plus 6y squared to this side. So that is gone. We're also going to subtract this 100x dy over dx, so that'll be gone. So minus 100 x dy over dx. So if I write this all out again, 2y, which why don't I pull this 6 back out to make this a 12y, dy over dx. Then we can just work with x squared plus y squared minus 100x dy over dx. The other side, then, we should have 100y minus 2, which, again, let's do the same thing there. Pull the 6 back out. 2x, 12x, x squared plus y squared. So from there, we can pull a dy dx out on this left side. So dy over dx. What would be left then is 12y x squared plus y squared. And here, minus 100x. Equaling our 100y minus 12x x squared plus y squared. And then we can divide this over. So dy over dx would equal this side of 100y minus 12x x squared plus y squared over 12y x squared plus y squared minus 100x. So, a lot going on, and this might be one of those parts where you want to watch it again and kind of see how this is all flowing. I'm sorry I kind of got you mixed up by distributing the 6 in. I should distribute the 6 in over here right away to make these 12s. That would have made it a lot less complicated. But again, you just want to get anything that has a dy dx on the one side. Anything else goes to the other side, and then you're solving for the dy dx. So pull that out front and divide the rest over. That's really what we're doing with these. And we didn't finish this because then we got to find the slope. So to find slope, we're going to replace every x with a 3 and every y with a 1. So dy dx, we would have 100 times 1 minus 12 times 3, 3 squared plus 1 squared. The bottom, 12 times 1 of 3 squared plus 1 squared minus 100 times 3. When you do all that, you should end up with, on top, a negative 65 over negative 45, which will come out to be 13 over 9 for an answer. All right, so now we can move on. So find dy dx of sine of x, sine of y equals x, and then find the largest interval for which y is a differentiable function of x. So this is kind of tying back to the equation of a circle that I kind of got mixed up on. So hopefully I'll do a better job explaining it this time. So dy dx, we have to find the derivative of this. And it's not even on the screen. So derivative of sine y equals sine x. Derivative of sine goes to cosine. So this would be cosine y. Derivative of the inside, derivative of y would go to 1. But because it was a y, it'll have a dy dx on it. Equaling derivative of x will go to 1. So to solve for dy dx, well, 1 times anything is itself. So we're just going to divide by cosine of y. So dy over dx will equal 1 over cosine of y. So if we think about it, well, where is cosine then not going to equal 0? Because that's really, because with it being on the bottom there, that's the only thing that it can't be is 0, because we can't divide by 0. Well, if we go look at the unit circle, so our x-axis, our y-axis, as we're going through here, we'd be at 1, 0. Here we'd be up at 0, 1. Here we'd be at negative 1, 0. and here we would be at 0, negative 1. So if you think back, our ordered pairs go cosine, sine. So we're looking for where's the first one 0 at? Well, down here at the bottom and up here at the top. So at pi over 2 and at, well, we're going to stick to this side. So if we rotate down, this would be negative pi over 2. Because remember, it can continue to go around. So going up is positive, rotating down is negative. So we're going to say it's from negative pi over 2, which is less than x, which is less than pi over 2. Is where we're going to be differentiable at. So that's where this, the derivative will exist at. All right, so last thing we got here is, just like with regular derivatives, we can find multiple derivatives of our implicit differentiation. We're doing those equations. So we're going to find the second derivative of this. So we're going to start by finding the first derivative. So derivative of x squared, we go to 2x, plus derivative of y squared, which would be 2y, dy over dx. And then derivative of 25 is 0. So now we can solve for the dy dx. So we'll subtract the 2x to the other side. And so 2y dy over dx would equal negative 2x. Divide by 2y. So dy over dx would equal, with those 2's reducing, negative x over y. So now on to the second derivative. So this is going to become dy squared over dx squared, which is just meaning the second derivative of the dy over dx. Second derivative there. This right side, though, we're going to have to do quotient rule with. So derivative of the top would be a 1, so negative 1 times our bottom y, minus derivative of the bottom, which would be 1, but dy over dx, times our top, which is a negative x, all over our bottom squared. So if we simplify now, dy squared over dx squared, negative 1 times y would be a negative y. These here would cancel, be a plus x dy over dx over y squared. Well, what is dy dx? We already found it here, so we can sub that in. So this is actually going to be a negative y plus x times negative x over y squared. The x's we can put together, and we can actually rewrite this. So dy squared over dx squared. We would have negative y plus x squared. Actually, that minus there would make it a minus there. Over y squared. And so then we can leave change flip. And this is going to become times then 1 over y squared. And this will get distributed in. So our front, we would have a negative y over y squared minus x squared over y cubed, which this here could reduce to a 1 and get rid of that. And so our final is going to be dy squared over dx squared, which is going to be equal to 1 over y negative minus x squared over y to the third. And I believe we're going to leave it at that. The notes take it just a little step further. but I think this is where we're going to leave it. So, last little bit here is define an equation of a tangent line, take the derivative of the function, and then plug in the point to find the slope. Then use that point and the slope in point slope form to write in the equation. So we'll find the derivative. You'll be able to find the slope from that derivative and then take the point and that slope, which point slope form is y minus y1 equals m parentheses x minus x1. And you can put it in there and find it. So, first lesson done. I'm sure you guys will have lots of questions. Please send me those questions and I'll try to answer them the best I can. You can rewatch this video again and then try to do the homework. And again, if you have questions on the homework, please send me those questions too, and I'll try to get to answering those as best I can. So, let me know what questions you have, and we'll see you guys later.